Okay, so far you should have a forward and a backward function. So in your setup here, if you tell it to go forward then backward, it should do just that. Just want to make a quick comment. Um, I put this in the setup and it's going to go forward and backward once. If you put this in the loop, it would do it repeatedly. So anytime you want it to just do something once, it's helpful to put it in the setup instead of in the loop here, because then it just does it the one time. Okay, so let's take a look at our functions. We have the distance to steps function we wrote to convert from our distance to a number of steps. We have our forward function that took the number of distance and actually caused it to go forward that distance. And now you should have also written the backward function, okay, that would do the opposite of forward. It would take a distance and have it go backward. And all you needed to do to change from forward to backward is to make these steps negative, okay? And everything else should be the same. We're converting distance to steps. We're iterating through those steps in this for loop, but this time instead of stepping forward each time, we're stepping backwards. Okay, the next thing we want to do is we want to create a function that will take some angle and turn. Okay, so maybe you could say, all right, so let's go left, turn left 90 degrees. Okay, and what that's going to do is turn Drawbot certain number of degrees. Okay, and the trick here, for this to work right, we want both wheels to move so that it rotates about its center. So there's actually, it's going to be rotating in place if we do this right, and so when we start actually drawing things, then when we turn, the pen doesn't actually move. Okay, and so what needs to happen here is that one wheel needs to go forward and the other wheel needs to go backwards. Okay, so let's go ahead and discuss how we might come up with this. We basically need to take an angle and turn that into a number of steps. Okay, so what we're going to have to do here is going to go from an angle to a distance. Okay, because remember, if we have a distance, we have already built a function that can allow us to turn the distance into steps. Okay, with this distance to steps function, our goal is to come up with a distance so that we can so we can take that distance to send it to that distance to steps and get the number of steps we want. Then we'll use this guy right here that we've used for the other ones to control it. And again, let's actually copy this whole stretch right here because all that's going to be the same basically. Okay. All right. The change though is that we want them to be going opposite. So if we're turning left, then if you want to imagine something turning left, the outside wheel, the right wheel is going forward and then the left wheel is going backwards. So right here, this is going to turn it left. Okay, and so we'll take this piece right here to convert our distance to steps. Okay, and then the last thing we got to do here is we need to figure out how to go from angle to distance. So let's go ahead and look at this picture right here. And we're going to talk about circles really quick. So here's a circle, and let's say that I want to go 90 degrees, which would be a quarter of a circle. So this, if I want to rotate 90 degrees, it might be like from here to here. Okay, that's a quarter of a circle. That means I'm going to travel a distance 1/4 of the circle's circumference. Okay, and so we know that circumference is equal to 2 times pi times the radius, and 2 times the radius is the diameter, so it's also equal to pi times the diameter. So this is helpful for us because if we can determine the circumference, that gives us a distance. So if we know the circumference of that circle it's rotating, that gives us a distance, okay? But in order to do that, we need the diameter, which I'll talk about measuring in just a second, okay? So what we can do is this. We know that one full rotation is 360 degrees, okay? And then we're going to give some angle that we want to rotate. That will be some fraction of a circle. So 90 degrees would be a quarter of a circle. That would be 90 over 360, which as a fraction reduces to 1/4. If it's 180, it's 1/2, and so on. And if we multiply this by our circumference, which is pi times the diameter, that would give us a distance. Okay? And so we're going to put this into our code in order to convert from an angle in degrees to a distance. So if we'd say our angle divided by the degrees in a circle, 360, times pi times our diameter, if we do all that, then that's going to give us the distance that each wheel needs to travel. And we'll have to make some tweaks later just because of the nature of the fact that both wheels are turning. Okay, so we're going to take this and put it into code here. So we'll say, okay, so we're going to say float distance. By the way, we've created this variable here, distance, that we're using multiple times. This is called a local variable, and what it means is we're creating it within these functions, and it only exists when that function is working, and then it goes away. And so we can keep reusing this word distance as a local variable, but every time we use it, we have to redeclare it. Okay, and so I'm declaring distance here. I declare it here in that backwards function, which vanished somehow. And so anyway, my point in telling you all that is that that's what's going on when we declare it here, is that we're kind of reusing it in our new function. So like, while it means something similar here as it does to there, these have no relationship because they represent an instance of that variable in a different function. Now, if a variable that you declare up here, these apply to all functions, okay? And so like we use pi, we use wheel diameter, things like that, and those are not local variables. I guess those would be public. I'm not sure what the correct term for that is, but those are variables that apply to all functions. Okay, so anyway, coming back to here, so the distance will be equal to, we said, angle divided by 360. Okay, and then we're going to multiply this by, we said pi, which we have pi up here, right? We just used a variable for pi. And we're going to multiply that times the diameter. Well, so we're going to actually have to measure the diameter. That would be the distance between your wheels. And we're going to give it a name, and we'll put it up here at the top. Okay? And so we'll say const. So make it a constant because it won't change. Also be a float because it will be a decimal potentially. And this will be wheel. We'll call this the wheel base. So this would be the difference between the wheels, and that's the diameter of our rotation. So if you measure on your Drawbot, this is one wheel and this is the other wheel, the diameter of your Drawbot is this distance between where the wheels touch the ground. Okay? And we're calling that wheelbase. Okay? So you're going to put that here under wheelbase. I'm going to make up a number because I'm not sure what it was. Let's say 134.6. Okay? Distance between wheels. Okay? And so now, when we want to multiply by diameter, we'll say wheel base. Okay? And this allows us to convert angle to distance. Okay? And then the last step from here, so we send that, we take this calculation, we store it in the variable distance, and then here we take that variable distance and we send it to our distance to steps function right up here. in which it's going to do this calculation to find out how many steps that would be to go that distance. We're then going to return that step count over to here. Okay, and it's going to store under the variable step count here. And then it's going to step through that and basically go one step forward for right, one step backward for left until we've gotten through all those. So when you're ready, you can go ahead and run it. You can, if you want to get rid of the forward and the backward, you can. And what you can set however many degrees. If you want to do one full circle, that'd be 360 degrees. If you want to do two, that'd be 2 times 360, or 720. If you want to do a quarter of a circle, it'd be 90. Half a circle is 180. Okay, try it out. See how it works. What you might notice is that it's not perfect. It might do a little less or a little bit more. And where that's going to come in is by the next kind of thing we're going to do is we're going to be calibrating these values for wheel diameter and base. And as we get these, as we narrow in on the correct values for these, then this will get more and more accurate. Okay, so once you've done this, go ahead and kind of repeat those steps and make a right function. Okay, so that we'll do something similar, except instead of turning left, it will turn right. Okay, that's the next step for you. Okay.